Good morning. In our last lesson we had a discussion about what we thought could affect the resistance of a wire. We agreed that there were four quantities that we needed to think about. We thought the length of the wire could affect its resistance, the thickness of the wire could affect its resistance, the material the wire is made from, and the actual temperature of the wire. What we're going to do today is we're going to see how the length of the wire affects its resistance. So obviously, to make this experiment a fair test, we will need to keep the thickness and the material the wire is made from the same, which is simple, and we need to keep the temperature of the wire the same. However, this is more difficult because the current which flows through the wire will actually affect the temperature of the wire. So I will need to use a circuit which allows me to keep the current the same all the time. So, I'm going to now show you how to build and use the electrical circuit which allows us to investigate how the length of the wire affects its resistance. Now to do this, we're going to use a simple equation. The resistance of the wire, R, equals the potential difference across the wire divided by the current which flows through the wire. Now to achieve this, I'm going to use a very simple circuit called a potential divider. I'm going to show you step by step how to build this, and then after I've done this you can go and do the experiment yourself. So the first thing that I do is I connect a type of resistor called a rheostat to the power supply. So I put two wires into the red and black holes on my power supply, and they go to the bottom terminals on my rheostat. I then connect the rheostat to the ammeter. Again, I use one of the terminals at the bottom of the rheostat and I connect that to the ammeter. And then in series with the ammeter, I connect my wire, which is on a ruler, so I can measure the length. And I then go back to the rheostat from the wire, but this time the wire doesn't go into the bottom terminal of the rheostat, it goes into the top hole. And finally, I connect the voltmeter in parallel with my wire so that I can measure the potential difference. Okay, so the power supply goes to the bottom two holes on the rheostat, go from one of the bottom holes on the rheostat to the ammeter, which is then in series with my wire on my ruler, and then from the wire back to the rheostat but to the top terminal on the rheostat, and then connect across the wire my voltmeter so I can measure the potential difference. So if I turn my circuit on, you can see that I'm measuring both the potential difference and the current. Don't worry about the minus sign, that's just showing us the direction which the current is flowing. We're only interested in the size of the current. Now, if I move this feeler, slider contact, you can see I can control the size of the current. I'm also controlling the size of the potential difference. But the important thing is I control the size of the current, so I can maintain the current at, for example, 0.3, well roughly 0.3 amps. And I would use that for each of my experiments. So I change the length of the wire each time, and then each time make sure that the current flowing through the wire is 0.3 amps, so that I know each time I'm using the same temperature as well. Thank you.